Supervised Fine-Tuning, the $10 decision. $100 million. That's the estimated cost of training GPT-4 from scratch. Fine-tuning a 7 billion parameter model to your needs via QLoRA, roughly $10 at 2023 GPU prices. Less than a team lunch. That cost difference isn't a marketing trick. It's the consequence of a process that transformed the entire AI industry. Supervised Fine-Tuning, or SFT, turns a useless text autocomplete engine into an assistant that understands instructions and answers questions. In the previous episode, we covered pre-training, the process where a base model learns to predict the next word on trillions of internet tokens. Today, we start exactly where pre-training ends. In this episode, I'll show you where that cost gap comes from, why a model 100 times smaller beat a giant in 85% of human comparisons, why 1,000 carefully selected examples competed with GPT-4, and how you can fine-tune your own model for the price of an office coffee. We start with a problem OpenAI discovered in GPT-3. The brilliant autocomplete that can't answer. GPT-3, when asked what the capital of France is, would generate more questions. What is the capital of Germany? What is the capital of Spain? Not because it didn't know the answer. In the raw internet data the model was trained on, such lists of questions appear next to each other. Statistically, that's the most sensible continuation of a sequence. Andrej Karpathy put it plainly in his Build 2023 talk. Base models simply autocomplete text. They're not assistants. Imagine a brilliant junior developer who has read every piece of documentation on GitHub. He knows every repository, every architectural pattern. You send him a production bug description, and he sends back the entire system source code. Not because he's incompetent, because no one told him that at this company we expect a concise incident report with the root cause and a patch proposal. SFT is the corporate onboarding of that employee. We're not teaching him to program. He already knows how. We're teaching him the communication protocol. When to respond, in what format, and when to stop talking. One key technical detail. SFT uses the same loss function as pre-training. Cross-entropy, predicting the next token. The difference lies entirely in the data. Instead of raw internet text, the model receives structured pairs with roles. System, user, assistant. It learns to generate responses conditioned on instructions rather than unconditional text continuation. Same engine, completely different fuel. OpenAI decided to fix the useless GPT-3 problem. The result shook the entire industry. When 1.3 billion beat 175 billion, the landmark publication from the OpenAI team, Long Ouyang and collaborators, NeurIPS 2022, established a three-step alignment pipeline. SFT, then a reward model, then PPO. The SFT step used roughly 13,000 training prompts with demonstrations of exemplary responses, prepared by a team of around 40 contractors. The results changed how the entire industry thought. Responses from the 175-parameter InstructGPT were preferred over GPT-3 in 85% of human comparisons. Even compared to GPT-3 with few-shot techniques, the model won in 71% of cases. The most important finding was different. The InstructGPT model, with just 1.3 billion parameters, was preferred over the 175 billion parameter GPT-3, a 100-fold difference in scale, and the smaller model won. Alignment proved more important than raw parameter count. The improvement wasn't limited to preferences. Hallucinations dropped from 41 to 21% on closed domain tasks. Response toxicity decreased by roughly 25%. Those results came at a price. InstructGPT lost points on benchmarks like Squad, Drop, and HelaSwag, a phenomenon known as the alignment tax, a drop in general performance after SFT. That's the price of better assistant behavior. OpenAI mitigated this through PPO-PTX, mixing pre-training data into the alignment process. The compute cost speaks for itself. Pre-training GPT-3 required roughly 3,640 petaflops per second times days. SFT required just 4.9, about 0.13% of the pre-training cost. SFT delivered the first and largest qualitative leap, from a useless autocomplete to a conversation-capable assistant. Full alignment still requires the complete pipeline: SFT, a reward model, and PPO. If 13,000 examples were enough for OpenAI, consider what happens when someone reduces that number to just 1,000. 1,000 examples that changed the rules. In May 2023, the Meta AI team, led by Chunting Cho, published the LIMA paper. They took a LLaMA model with 65 billion parameters and fine-tuned it on just 1,000 rigorously selected examples. 400 from Stack Exchange, 200 from WikiHow, 150 from Reddit, 200 written by hand by researchers, and 50 from supernatural instructions. The results shocked the community. LIMA was preferred or rated on par with GPT-4 in 43% of cases, against the Claude model in 46%, against Bard in 58%. Half of the responses were rated as excellent. 88% met the prompt requirements. The authors formulated the superficial alignment hypothesis. The model's knowledge and capabilities are acquired almost entirely during pre-training. SFT only teaches the model what format to use when interacting with users. SFT is makeup, not surgery. It changes how knowledge is presented, not the knowledge itself. Mechanistic evidence came from the Uriel study. 77.7% of tokens don't change position between the base model and the aligned model. Changes affect primarily stylistic tokens. LIMA's ablation studies confirmed the quality over quantity thesis. Doubling the data brought no significant improvement. Filtering for quality, on the other hand, improved results by half a point on the Likert scale. The superficial alignment hypothesis isn't the whole truth. Studies from 2024 showed that for mathematical reasoning and multi-step inference tasks, more SFT data continues to improve results, well beyond the format saturation point. For 7 billion parameter models, 1,000 examples may not even be enough to learn the conversation template itself. The consensus, the hypothesis holds for chatbot alignment, but is an oversimplification for reasoning tasks. Since data quality matters more than quantity, the question of which SFT datasets are best remains, and why a bad data format can destroy even the best model. Chat template, the silent model killer. A chat template is a communication protocol that formats a conversation into tokens with roles: system, user, assistant. Each role separated by special delimiter tokens. It works like an API contract. It defines who's speaking, where a message starts, and when the model should stop generating. Different model families use different formats. OpenAI's ChatML operates with im_start and im_end tokens. Stanford's Alpaca uses instruction and response markers. Llama 3 introduced dedicated special tokens. Each format encodes roles and message boundaries differently. That's where the problem begins. Using the wrong format is a silent failure. The model won't throw an error. The endpoint will return a 200 status code. But response quality drops dramatically because the model receives data in a format it doesn't understand. It's like sending an XML document to a JSON parser. Semantically, the data may be correct, but the system won't process it. Hugging Face standardized template handling through the apply chat template method, which uses Jinja templates from the tokenizer config. One of the key settings, add chat prompt, adds the assistant header, triggering response protective the sum term of their grounds. The first user is the memory formats of Eden-Biter method. It finds troubled formats because leaving the chat pod new to. A small parameter with an enormous impact. The second key behavior taught by SFT is generating the end-of-sequence token, known as EOS. A base model generates indefinitely. A fine-tuned model knows when to stop. An apparently minor change that turns an infinite autocomplete engine into a model that gives concise answers. During SFT, the entire sequence goes into the model, but the loss is computed only on the assistant response tokens. This loss masking ensures the model learns to generate responses, not to replay the question. Like a code review, you evaluate the developer's response to a ticket, not the content of the ticket itself. Data format and quality are the foundation of SFT. Full fine-tuning of a 65 billion parameter model requires hundreds of gigabytes of GPU memory. There's a way to do the same thing for $10. LoRA and QLoRA, fine-tuning for $10. Instead of modifying all the billions of weights, LoRA freezes the entire base model and trains miniature adapter matrices alongside it. Low-rank adaptation, a small patch next to a large system. Like a plugin for a frozen application. The mechanics in brief. The base weights remain frozen. Two small matrices, A and B, are created alongside them. The model computes output as the sum of the original weights and their correction through the adapters. Matrix B starts at 0, so the model initially behaves identically to the pre-trained version. No knowledge is lost at the start. The efficiency numbers are spectacular. GPT-3, 175 billion with rank 4, gives just roughly 18 million trainable parameters, below 0.01% of the original. The checkpoint shrinks from 350 gigabytes to 35 megabytes. After training, LoRa adapters can be merged back into the base model. Zero additional inference latency. QLoRa goes one step further. It combines LoRa with compressing the base model to 4 bits. 3 innovations. NF4 quantization, optimal for weights with a normal distribution. Double quantization, saving roughly 3 gigabytes for a 65 billion parameter model. And paged optimizers. Automatic page transfers between CPU and GPU. The effect changed the accessibility of SFT. A 65 billion parameter model fine-tuned on a single GPU with 48 gigabytes of memory, compared to over 780 gigabytes required for full 16-bit training. Guanaco 65 billion achieved 99.3% of ChatGPT performance after just 24 hours on a single GPU. The cost spectrum at 2023 GPU prices. Pre-training GPT-4 estimated $100 million. Full fine-tuning of a 7 billion parameter model in the cloud, roughly $1,500 to $2,500. QLoRa for the same model, $10. From a big tech lab to a single laptop. The democratization of SFT in one sentence. The QLoRA authors independently confirmed the LIMA thesis. The OASST1 dataset with 9,000 examples outperformed Flan v2 with 450,000 on the chatbot benchmark. Quality beats quantity, consistently. We have the tools, the data, and the method. The remaining question, when to use SFT and when prompting or RAG will do. When SFT, when prompting, when RAG. Maxime Labonne, head of post-training at Liquid AI, advises directly. Before considering SFT, it's worth trying prompt engineering and RAG. If those approaches don't meet the goals, only then does SFT become a sensible option. Always start with prompting. SFT is the last resort, not the first move. The practical decision matrix looks as follows. A problem with response format, style, or tone, SFT is the right tool because it teaches the model structural behavioral patterns. A problem with current or specialized knowledge. RAG because SFT is poorly suited for injecting new facts and carries a hallucination risk. A one-off or rapidly changing problem. Prompting or few-shot with no investment in a training pipeline. A problem with structural behavior. For example, the model must always respond in JSON format. Again, SFT. The warning is clear. Using SFT to learn new factual knowledge often leads to hallucinations and catastrophic forgetting, the phenomenon where a model forgets previously acquired skills after fine-tuning on narrow data. A silent failure. The model doesn't generate an error. The endpoint returns a 200 status code, but responses are degraded or incoherent. A case study from the Polish AI scene. The Bielik 11 billion parameter model, created by the Speaklish community in collaboration with ACK Cifronet AGH, went through a full SFT pipeline on over 20 million Polish language instructions. The creators stood out for an innovative approach, weighted cross-entropy loss. Examples verified by hand by domain experts received full weight. Mechanically verified examples, reduced weight. Synthetic data, even lower. A model application of the quality over quantity principle at production scale. At the Poleval 2025 conference, a model from the Bielik family was used to build linguistic inclusivity tools. Using just 1,728 training instances, QLoRA, and a single GPU card, proved that PEFT works even at microscale. SFT doesn't build the model's brain. It teaches it how to work with people. Summary and what's next. 5 things worth taking to the office on Monday. First, SFT doesn't teach new knowledge. It teaches communication. InstructGPT 1.3 billion beat GPT-3 175 billion because it communicated better the knowledge the model already had. Second, data quality beats quantity. LIMA, with 1,000 examples, competed with GPT-4. Investment in data curation delivers higher returns than collecting larger datasets. Third, chat template is the silent killer. The wrong format doesn't generate an error, but it destroys response quality. Always use exactly the template the model was trained on. Fourth, LoRA and QLoRA democratized SFT. Fine-tuning a 65 billion parameter model on a single GPU for $20 to $30. A checkpoint of 35 megabytes instead of 350 gigabytes. That changes the build versus buy equation. Fifth, SFT is a tool for changing behavior and format. New knowledge is better delivered through RAG. One-off tasks are solved with prompting. Always start with prompting. SFT is the last step, not the first. If this video was valuable to you, subscribe to the channel so you don't miss future episodes. Leave a comment below letting me know whether your team has considered fine-tuning your own model and what budget you've set aside for it. In the next episode, the reward model and RLHF, when a demonstration of an exemplary response isn't enough and you need to start comparing.